Hey everyone, welcome back. Now that you're comfortable with rational expressions and how to simplify them, we're going to look at how to multiply and divide rational expressions. So multiplying rational expressions, you multiply just like you would multiply two fractions together. So if we have the rational expression a over b, and we multiply it by the rational expression c over d, we just multiply the numerators and multiply the denominators, and we get the new rational expression a times c over b times d. So let's look at two examples here. We're going to multiply and simplify to lowest terms and leave our answers in factored form. Now whenever you multiply rational expressions, it's easiest if you can factor them. So you'll factor them, and when they're all in their factors, combine the numerators, combine the denominators, and then simplify. So our first numerator is t plus 1 squared. Well, that factored out is t plus 1 times t plus 1. And this first numerator gets multiplied with the second numerator, which is t plus 2 squared, or factored, that's t plus 2 times t plus 2. And we put that all over the denominator. The first denominator is the term t plus 2, and the second denominator is the term t plus 1. Now to simplify, we're looking at what the numerator and the denominator have in common. Now our numerator and denominator here both have factors of t plus 1 in common, so those simplify with each other. They don't cancel out, they simplify to 1 because t plus 1 divided by t plus 1 is 1. And the same with the factor of t plus 2 that they both have. That simplifies out. So we're left with a numerator of t plus 1 times t plus 2. And our denominator is just 1. So we can put this over 1, but remember anything divided by 1 is itself. So the answer is t plus 1 times t plus 2. And we want to leave it in factored form, so we stop here. Now, example 2. Our first numerator is x squared, which is the same as x times x. And our second numerator is x plus 4. Well, x plus 4 can't be factored, so it just stays as the factor x plus 4. And then we look at our denominators. The first denominator is x squared plus 4. Well, this is the sum of squares, x squared and 4 is a square, but you can't factor the sum of squares. So this just stays as the factor x squared plus 4. And then our second denominator is an x. So everything's factored, so we compare the numerator and the denominator, and the only factors they have in common are an x. So those simplify out, leaving us with a numerator of x times x plus 4 over a denominator of x squared plus 4. Let's look at example 3. This example is a little more challenging only because that first rational expression has a trinomial for the numerator and for the denominator. So we want to factor those trinomials first, and then we can multiply our numerators and our denominators. So look at that first numerator, 2x squared minus x minus 3. Since this trinomial has a leading coefficient other than 1, we need to use the key number method, which if you remember is a times c, or 2 times negative 3, which is negative 6, and b, the coefficient of our middle term, which is negative 1. So we use these values to find two numbers that multiply to negative 6 but add to negative 1. So we get the terms 2 and negative 3. And those are the values we use to rewrite that middle term. So we end up with 2x squared plus 2x minus 3x minus 3 as our new polynomial. And now that we have 4 terms, we factor by grouping. So the first two terms have 2x in common. So we have 2x times x plus 1. And those last two terms have negative 3 in common. And we're left with the binomial x plus 1. And now that you're down to the two terms, you factor out that binomial x plus 1 that they share in common, and you're left with the binomial 2x minus 3. So on the far right here, we can rewrite that numerator, x plus 1 times 2x minus 3. Now we're going to move on and look at the denominator of that first rational expression. So we need to factor 3x squared minus 8x minus 3. And again, the key number, AC, here is negative 9, and our B is negative 8. So the two numbers that multiply to negative 9 but add to negative 8 would be 1 and negative 9. So our polynomial would be 3x squared plus 1x minus 9x minus 3. And again, factor by grouping. So the first two terms have an x in common, and that leaves 3x plus 1. And the last two terms have negative 3 in common, and that leaves 3x plus 1. We factor out that binomial, 3x plus 1 that they have in common, and we get the binomial x minus 3. So our new denominator for that first rational expression is 3x plus 1 times x minus 3. And now we can multiply the other numerator and the other denominator in. So we multiply that numerator from the second rational expression, which is 3x plus 1, and the denominator 2x minus 3. And just like we did above, we compare the numerator and the denominator. The terms that they have in common, they have the factor of 2x minus 3, so those simplify out, and they both have a factor 3x plus 1, which simplifies out. So our final simplified expression is x plus 1 over x minus 3. So you really have to be good at factoring. If you're struggling with factoring, I encourage you to go back to the factoring videos, work through those factoring problems a few more times until you get comfortable. Because once you're comfortable with factoring, you're really just factoring these rational expressions and simplifying them down as small as you can. So let's move on to page 2, and in page 2 we look at how to divide rational expressions. So when you're dividing rational expressions, you're really still just going to multiply. So you have the first rational expression, a over b, and you're dividing it by the second, c over d. But this is equivalent to maintaining that first rational expression, a over b, and multiplying by the reciprocal of the second. So notice that you just flip that second fraction. So some people remember this as copy dot flip. So that's an expression commonly taught in the high schools, and what it's reminding you to do is that you're copying your first rational expression. You're changing division to multiplication, the dot symbol, and then you're flipping or multiplying by the reciprocal of that second fraction, your divisor. So let's look at an example. Example number 1, we're going to keep our first rational expression, x minus 2 over 3x. We're going to change this to multiplication, and we multiply by the reciprocal, 6x over 2 minus x. And then we can just factor, multiply our numerators and our denominators together, and simplify. So everything here is really factored. It's x minus 2. We could factor 6. 6 is 2 times 3, and then it's also times an x. And then our denominator, it would be 3 times x times 2 minus x. So now we look for anything that they might potentially have in common. The numerator and the denominator both have factors of 3 in common, so those simplify out. And they also have the x in common. But the one that should stick out, because they're opposites of each other, x minus 2 over 2 minus x. Remember that when you have a rational expression in this format, that simplifies to -1. So that simplifies to -1 times the only other factor we have left is 2. So our final simplified form here is -2. Now let's look at example 2. Our first numerator is a difference of squares. We have y squared minus 9, and 9 is 3 squared. So we factor using the difference of squares, y minus 3 times y plus 3. And then our denominator is also a difference of squares. It would be y minus 5 times y plus 5. We change our division to multiplication, and we find the reciprocal of that second rational expression. So the reciprocal of our divisor here is y plus 5 over y plus 3. And now we can multiply our numerator together. So y minus 3 times y plus 3 times y plus 5. Multiply those denominators together to get y minus 5 times y plus 5 times y plus 3. And then we're at the simplifying stage. So what factors do our numerator and our denominator have in common? Well, they both have the factor y plus 3, so that simplifies out. And they both have that factor y plus 5, so those simplify out. So our simplified form here is the expression y minus 3 over y minus 5. How about one that's a little more challenging? So example 3, we have a bunch of different challenging things going on. So let's just start on the top left, that first numerator. So the first numerator is actually a difference of squares. So let's factor that, and we get x minus 1 times x plus 1. Now, sticking with that first rational expression, the denominator there is a trinomial. And we're hoping we can factor that trinomial. And if we can, we should get 2 binomials. So we need the factors that multiply to -6 but add to 5. And it actually factors. That would be a positive 6 and a -1. And then notice that it's being divided by x plus 1. Now, x plus 1 isn't really a rational expression, right? It's just a binomial. But we can write that as x plus 1 over 1. And now we have a rational expression. So we're going to take our first rational expression and rewrite it. And then our next step is to change from division to multiplication and multiply by the reciprocal, or 1 over x plus 1. So we can combine the numerators, so x minus 1 times x plus 1 times 1 over the denominator of x plus 6 times x minus 1 times x plus 1. Everything's factored, so our last step, identify the factors that the numerator and the denominator have in common. I see an x plus 1 in common and an x minus 1 in common. So that means our simplified expression here is 1 over x plus 6. See, it looked a little daunting at first, but because we have strong factoring skills, we were able to factor each part and then just slowly simplify it down. So factor, factor, factor. Have a question or a problem you want help with? Leave it in the comments and I'll include it in one of my videos. If this video was helpful, subscribe to my channel for more math tutorials. Thanks for watching. See you next time.